Okay, this March 20, 2022. Wow, March 20, 2022. Wow. Okay, so we go now to the third topic, but I think we're gonna continue tomorrow for the osmotic pressure. If we still have time, then I can go directly, but I still have to eat my dinner. Okay, so number three. So I have to introduce to you a theory. Okay, sometimes also, guys, the question in the future also will try to trick you out regarding the laws, principles, concepts like that. So I may tell you that the vapor pressure lowering is just the same with the principle of Raoults law. Okay? Sometimes if you try to compute what is the value of this blah 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 so and so like that, is this obeying the law of A, B, C, D Henry's law, C, Nernst-Simon's law, and there's a law, too much laws in chemistry and physics. Okay? So it's gonna be like that. At least you are familiar that the Raoults law is just equal to the vapor pressure lowering, which is a part of qualitative properties topic in general chemistry lecture. Okay? It's gonna be like that. And since the vapor pressure lowering is obviously we're talking for the pressure, right? As an operating parameter or operating condition, and as I told you a while ago, boiling point elevation and freezing point depression are talking with the temperature, right? Now talking of pressure, and now before starting, we will maximize the units of pressure. Okay, atmosphere. Okay, one atmosphere is equal to 760 millimeters mercury. Okay? One atmosphere is equals to 1.013 bar. 1.013 bar, which is commonly the gauge pressure of different work equipment, could it be a rotating equipment or a stationary equipment. So usually there's a built-in pressure gauge for that. Okay, it's gonna express in bar, and there's also equivalent PSI, pounds per square inch. So you can say one atmosphere also as 14.7 pounds per square inch. That's why it's become PSI. P stands for the pound because the first letter of pound is P. Okay? Square inch because the first letter of square is S. Inch because the first letter of inch is I. Meaning to say PSI is an acronym for pound per square inch. So one atmosphere is equal to 14.7 pound per square inch or just PSI, something like that. Sometimes also in problem solving in engineering, we have also absolute pressure. So it's gonna be represented as PSIA, meaning to say PSIA is an absolute pressure in terms of pound per square inch. That's a PSIA or PSA. It's just the same. Absolute pressure. Okay. Now we go to another value of pressure. We have the torr. Okay. 760 torr is equal to 1 atmosphere. Okay, like that. And then also we should not forget the Pascal's law of partial pressures, the Pascal units. Okay, 1 atmosphere is equals to 101,325 Pascal. Okay, then if you convert that to kilopascal, because that's too huge, 6 digits, so some books represented that as 101.325 kilopascal. Okay, 101.325 kilopascal is also equal to 1 atmosphere. Okay, so since Pascal is equal to 1 Newton meter squared, then bingo, we can solve for the force applied. And we can solve also to the distance covered when you apply a force, when you push certain things, when you do output in your machine or your equipment, because you have the formula, force is equal to pressure over area, then bingo, you can solve also for your force by having this Pascal alone as the unit. Okay? For example, the pressure is 125 Pascal. Jun push the object. What is the force applied in Jun? We can compute because the formula of Pascal is equal to Newton over meter squared. If I were measure the distance I covered during I push the object and I use the tape measure or a ruler to compute for the horizontal distance in the floor, I push the object, then therefore we conclude technically that I have the force applied. Even though the unit is only one or the data is only one is Pascal. You get the point? Any questions so far for the maximization of units of the pressure? So, generally, we can conclude that 1 atmosphere is equal to 716 mmHg is equal to 1.013 bar is equal to 47 pounds per square inch is equal to 101,325 Pascal is equal to 101.35 kilopascal. That's all. Okay? But sometimes also, other books references, they will just say 1 atmosphere is equal to 1 bar. Because the 0.013 also something chuba chuchu, 0.013 is sometimes also negligible and irrelevant. But to make it technically precise in your final answer, for me, in my part when I was in college and in high school, I always carry this 0.013 bar because during the choices of the multiple choice, you know, there's an issue. You will carry everything the points there and you will be wrong if you're only using 1 atmosphere is equals to 1 bar. So you should use that perfectly as 1.013 bar is equals to 1 atmosphere. For me, I suggest not use 1 bar. Okay? Because during your conversion, it will matter if there's a lot of figures chuba chuchu somewhere along your conversion factor. Okay, any questions so far for this units of pressure maximization? Maximization is the process of maximizing different units of pressure. The act of maximizing. That's why maximization. You get the point? That's a process when you add TION, that's a process. That's an operation in English. Okay, for example, evaporation, vaporization, crystallization. You add ION in the last 3 letters in the term. So that's process or operation. That's why I say maximization. Okay. From the root word maximum. Okay, that's why maximize is the verb and the process is maximization. And it will become now a noun. Okay, so going back to the topic, it was problem number 3. Di ba ang saya-saya if you combine English, math, and science? Okay? So for me, that's the very, very important subjects for me. Okay? Math, science, and English. No other. For me lang. Okay, correct me if I'm wrong. Okay, number 3. Okay. So, question number 3. 30 grams of glucose. Andiyan na naman tayo, glucose. Okay. Walang katapos ang glucose. Okay. Sige. Go. Charot. 30 grams of glucose, mga kapatid. Okay, glucose. It's very lucky, we're very lucky, right? We discussed yesterday about the carbohydrates family, the sugar family, and then we don't have an issue to how to make the chemical formula of glucose, sucrose, galactose, blah, 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 blah. Okay, if you're just listening in my yesterday's vlog, if you can still remember, then bingo, we are very, very lucky today, right? Now, going back to question number 3. So, 30 grams of glucose, okay, mga palangga, is dissolved with D ha, past tense. Kaloka. Pati past tense. Okay. In 500 ml. Okay. Of water. Grabe naman, water. Water. Okay. At 25 degrees Celsius. Okay. And then, what is the vapor pressure? Okay. What is the vapor pressure? Okay. In engineering, guys, always pressure computation and temperature computation. Malula ka talaga sa mga ng mga questions. Temperature, pressure, like that. It's always starting from the first year college until graduation. Temperature and pressure will never disappear in your subjects. Really. Until your board examination. Okay, what is the vapor pressure? Okay, nakakaloka mga kapatid. Okay, of the solution. okay, of the solution. Ganun. Okay. The vapor pressure of water. Actually, this is the standard for water. I think no need to write because I memorized this already. But for the sake of discussion, I have to put, okay, vapor pressure. That's why I advise you to memorize the basic, ha? Because sometimes the question will not put every time the standard on the problem. The vapor pressure, okay. Hindi kayo magpaabot ng permit sa standard in the thumb chart. Okay, is 23.8 tour at 25 degrees. Kapoy mo magsuwat, guys. Okay. And the density, wow, i-connect yung density. Density of water, nakakaloka. I have to contest with this one, ha? I will fight this one. Maybe this is wrong. Okay, based on my memorization. Okay, 1 gram per. I found it inconsistent. Let's check. Okay? Sometimes I need to argue with the sample problems. There's sometimes errors. Okay, but anyhow, that's also clerical, right? We don't know. Okay, I need to contest and object this last part. This is actually taken from Harvard University sample problem in their chemical engineering department. Okay, but why this? The vapor pressure of water is 23.8 torr at 25 degrees Celsius, and the density of water 1 gram per ml. Sure? Wait. Again, the sentence goes like this. There's no comma. The vapor pressure of water is 23.8 torr at 25 degrees Celsius, and the density of water is 1 gram per ml. Would it mean that this density of water at 25 degrees Celsius is it's another story? Because the word and is a continuation, right, in English? And. Okay, how can we interpret this one? Because I know, based on my memorization since high school, that the standard temperature of water is 4 degrees Celsius to obtain 1 gram per ml. And this problem states that, see, the vapor pressure of water is 23.8 torr at 25 degrees Celsius, and the density of water is 1 gram per ml. Would it mean at this temperature or not? Because the word and is a conjunction referring to the same sentence. Oh, never mind. Okay? You get the point. And I'll double check that in the books if it is really 4 degrees Celsius. If we can obtain 1 grams per ml. Maybe I was also wrong. Because that was 20 years ago. Okay, how can I memorize everything regarding, constants and values or standards, right? Okay. So, never mind. Just look that this way only for the purpose of understanding only and how to solve it properly, right? Okay? So, mga kapatid, asa naman to? Okay, solution. Ganon. Kaloka. Okay? Guys, since I know, Raoults law is a theory that states when you add a non-volatile solute to a particular solution, the vapor pressure of the solution will decrease if there will be an increase in the number of moles of solute and the concentration of the solute. Ganun siya. Okay? So, it's gonna be like vapor pressure of a solution. So, P solution, like that. P stands for the vapor pressure, and then X. So then X stands for the mole fraction of solvent. Solvent here is water. Because sometimes also, the solvent will be ethanol, chloroform, acetone, refrigerant, like that. Especially if your solution is composed of liquid solvent, like that. And you need to identify the solute in terms only in their amount. If the amount is higher, then it's going to be the solvent. If the amount is lesser, that's going to be the solute. Because technically, by theory, the solute is always lesser than the solvent. Something like that. Okay, correct me if I'm wrong. Okay, so that is not the case if all are liquids. But sometimes, solid and solvent will be there, most common. Okay, so in this kind of problem, we don't have to worry because our glucose is a solid. Okay, like that. It's not liquid. Since we know water also is a liquid. Okay? So, mole fraction of solvent, or we can go directly to water to make it specific. Okay, mole fraction of water. Okay, times the vapor pressure of water also. Okay, solvent naman ko yan siya guys mga palangga. Okay, now we have the theory already that the vapor pressure of the solution is less than or lesser. Okay, so lesser to the pressure of your vapor pressure of the water. So it's gonna be like this in math. The arrow is greater than lesser than the vapor pressure of water. Okay, so this one in math, greater than, lesser than, greater than, equal to, like that, blah, 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 so and so. Okay, so muna siya. Kaya ikog diri man sa luyo, that means lesser. Okay? Pero kung ang buka niya, gikaon ganin niya ang buka, ang pressure water, gikaon siya, greater na siya. Okay? So that will be the clue. O greater than, lesser than, ganon. Okay. So muna siya ang first theory. Vapor pressure solution is always lesser than the vapor pressure of water. Okay. Now compute individually each quantity. So mole fraction of water, we can compute this, of course. Vapor pressure of water, it's given, I think so. Yes, it's 23.8 torr. Wow, ang torr pa dyan gihatag na pressure in which that is not very common. Torr, T-O-R-R. Okay, so namatadaan, we have now the vapor pressure of water, 23.8 torr. Then our problem only is to solve for the mole fraction of water. Okay, how to compute mole fraction of water? So, mole fraction of water is equal to the moles of water, okay, mga palangga, over the moles of water plus moles of the solute, which is our glucose, right? Then we can say technically that the moles of the glucose plus the moles of the water will be equal to the moles of the entire solution, right? Now do it individually with patient, okay? Because it's very tasky, right? So we need to compute for the moles of water and moles of glucose. Now, it's easy to solve first the moles of glucose, right? Because we have 30 grams of glucose. Here, then, link this with the molar mass of glucose, as I said trillion times ago. A trillion times I speak, if you have the grams of solute, link that with the molecular mass. And Baden to the number of moles in the stoichiometric relationship in your chemical reaction or dissociation chemical reaction or whatever, okay, like that. Okay, so 30 grams of glucose. So see, glucose. Now, if you are struggling for formulation and chemical formula naming, you will be lost because this is written in words. Glucose. What is the formula of glucose? And then if your examination is not open book, and if your examination, normally it's not open data, there's no mobile data, you cannot Google search. So how can you do that? So, as I told you, memorize as early as you could. If you are still a senior high school chemistry students now, first year college students now, and you have chemistry lectures for semesters, then you have to memorize the chemical formulas of the most common compounds and elements in the periodic table, something like that, okay? Get the point? So, if you're struggling with the naming, right? So, good if you memorize a lot of the carbohydrates family, right? And the, glucoses family, right? Okay, so glucose, so carbon, 6H12O6, okay? So there are 6 atoms of carbon, 12 atoms of hydrogen, 6 atoms of oxygen. Now, molar mass, molecular weight. Oh, carbon, 6 times 12. Okay, hydrogen. Diba? Hydrogen, 12 times atomic weight of hydrogen, 1.008. Okay, 6 times atomic weight of oxygen, 16. Ganun. So without periodic table, you can go conveniently because you memorize the basic atomic weights of the basic elements listed in the periodic table. Especially CHO, guys, memorize na guys. Okay, CHO, carbon, hydrogen, oxygen. Okay, and nitrogen also, the inert gases or noble gases in the last group of the periodic table. Okay, 6 times 12. Mga palangga. 6 times 12 is equal to 72. I think so, yes. 72. Ganon. 72. 12 times. I think it's gonna be 200 plus. I'm not really that sure. Okay. 12 times 1.0008 mga palangga is equals to 12.096. 12.096. Okay. And 6 times 6 is simply equal to 96, right? 96 by visualization. Visualization. Okay. So 72 plus 12.096 plus 96 is equals to, oh my gosh, 180 point something for glucose. Okay. 180.096. Okay. Gram 1. Review. Okay. If you found, oh, it's gonna be like, gamay na siya, review. Okay. So 6 times 12. Okay. 72. Okay. 12 times 1.008. Okay. 2.096. Nakakaloka. 6 times 16 is equal to, okay, bingo. 2.096 plus 72, diba? Okay. 180 grams per mole, your molecular weight of glucose. Now solve for the moles of glucose. Okay, you have the weight of glucose or the mass of glucose, which is 30 grams. So 30 grams of glucose, okay, C6H12O6 times the molecular weight. So we will reverse because the grams in the denominator so that we can cancel out the grams. Okay, 180.096 grams glucose. Okay, and then mole, right? Mole of glucose. And then cancel somewhere along the way. Okay, grams, and we have the moles of glucose. Okay, calculator please. Okay, so we have, pas ako guys, I'm very fast, right? Okay, so 30 divided by 180. Gutom mo guys, gutom ko kabush. 30 divided by 180.096 is equals to 0.166 mga palangga. So I could say 1.67, round off. So 0.67, 1.6, ano yan? 7 moles. Okay, nanata. Okay, nanata yung glucose ko. Talaga. So our problem now is the moles of water. So we need to take account the data of water here. Look back to the problem. The vapor pressure of water is 23.8 torr. Okay, and then at 25 degrees Celsius, the density of water, 1 clarified half. Okay? So we could relate the moles in the getting the mass first, and after that, link to the molar mass, right? Okay. So it's gonna be like what mass of water is equal to mga palangga, density of water is equal times the volume of water, right? The density of water is 1 gram per ml times the volume of water is specified here or not? Okay, the volume of water is, okay, it's 500 ml of water. Okay, so 500 ml of water. Because sometimes also we need to have a basis of calculation if the volume is not mentioned. Normally 100 ml, 100 ml of solution, 100 gram of solution. If there's no other, given or mentioned in the problem, mapugustag basis of calculation. But in here, it's given, so no need to worry. Okay, so cancel the NL is equals to 500 grams. So 500 grams, convert to moles. What is the molecular weight of water? Tadadang! I memorized it already. It is 18.016 grams per mole. It's very easy. So it's gonna be like that, 18.016 grams mole. I memorized this because it is water. Water is life. How can I forget water? Right? So that's why I memorize everything, the water, the specific capacity, the heat capacity, the density, like that. So I memorize all about water because water is life. I cannot live without water. Diba? So you need to memorize the physical properties of water if you are taking engineering or specifically chemical engineering in this chemistry. Okay, we have 500 divided by 0.16 mga palangga. Okay. 500, kasi sa kuno, divided by 18.016 is equal to 277.53 mga palangga. 200 again. 500 Okay. Grams naman siya mga palangga. No. Divided by 18.016 is equals to 27.75 moles. 27.75 moles na natay water, moles of water. So substitute that here. Moles of water is 27.75 moles. And here also 27.75 moles. Okay. And then we have also the moles of glucose. We already computed a while ago, right? 0.167. Okay. Based on my memorization, I did not put, right? Okay. Good, I memorized. 1.67 moles. Okay. I erased that. Sure. Because the space in my whiteboard is very limited. I cannot expand my writings. Okay, 0.167 plus 27.75 chuba chuchu, 27.917, 27.917 mga palangga, 27.75. Okay, pila na ni siya. Okay, atong i-divide, di ba? Okay. I-divide na itong yan kung ano pila dyan siya. Okay? 27.75 divided by 27.917 is equals to 0.994. 0.994 is our mole fraction. Guys, mole fraction is without unit. Meaning unitless or without unit because it is a ratio. When you speak about fraction, that is a ratio between two numbers that consist of a denominator and the numerator. Meaning you divide. Okay, something like that. That is a ratio. You cannot say a ratio if there's no two quantities. It's always be the denominator, okay, downward, and the numerator upward. Okay, that's also named as fraction. Two types of fraction, improper fraction and proper fraction. Improper fraction, the numerator is higher and greater than the denominator. Okay, something like that. So that's ratio. That's why we have ratio and proportion in math. Okay, so 0.994 is the mole fraction of solvent, and then substitute now that here. So vapor pressure of solution is equal to 0.994. Okay, no unit because unitless. Okay, vapor pressure of water is 23.8 torr. So we'll carry, I don't know what's the pronunciation. Okay, 0.994 times, times 23.8 torr is equals to 23.66. Wow. So our vapor pressure of the solution is 23.66. Okay, torr. And then if the problem will ask you to how many that in mHg, in kilopascal, like that, and I told you a while ago in my introductory discussion, right? So you can convert that one because sometimes also in the problems in the future examination, it will be converted. What is the vapor pressure solution in kilopascal? Like that. And then this 23.66 also will be in the choices. Since this 23.66 in your, you got this correctly, you will take this as an answer. You will become wrong because the vapor pressure solution that is being asked in the problem is not the torr. Because too much fast in your solution and you taking for granted the correct conversion. Especially you're taking so fast and you run out of time to compensate the time limit of the examination. For example, 3 hours, 4 hours, and there's 200 questions like that. Okay, so be careful also with the unit of measurement conversion. Okay, so this is 23.62. Now we go to the theory. Is this answer is valid, logical, correct, like that, or reliable, something like that? So, okay. Going back to theory. Okay. So, vapor pressure of a solution. Ganon. What will happen to the vapor pressure of a solution when you add non-volatile solute? Okay. What will happen? As I told you earlier, it will be less than the vapor pressure of water. Okay. So, what is your vapor pressure of water? 23.8. And your answer is 23.66 of a matter of point something. So 23.8 minus, okay, 23.66. So you have decreased your vapor pressure of solution to 0.14 difference. 0.14. Now, if the question also in the examination in the future, you will say, what is the percentage difference of the pressure? Okay? It's not asking the vapor pressure of the solution, but asking directly, what is the percentage pressure difference of your vapor pressure of solution? Okay, you will still compute first the vapor pressure of the solution and get the formula of the percentage difference. I will teach you percentage difference in math. Percentage difference is equal to larger minus lesser over larger. Okay, larger is 23.8. Okay, lesser will be, okay, 23.66 over larger. So this is your percentage difference times 100. Because sometimes also not word for word all the time that it's gonna be like this. You have also to think what is being asked to support your the theory of the problem or the question. Okay, like this, 23.8 minus 23.66 is equals to divided by 23.8 is equals to 1 to 2. So it's gonna be 0.58% difference. Okay? Or 58% of your pressure was being reduced when you add 30 grams of glucose in your solution of water. Like that. Okay? So that's correct. So the first thing to do is you have an idea that your answer is always lesser than bingo. If it's higher, then problem. Even though how hard you try in your solution, it's also wrong. It's always wrong because you did not meet the theory, principles, and concept. Okay, get the point? Okay, class. That's why problem solving is just secondary for me. Okay, really, the most important is the theory, principles, and concepts. Okay, that's why I told you I'm not good in math. Okay. It's gonna. Okay, any questions so far? Any questions so far? If you like this video, you can comment, you can like, and then you can subscribe my YouTube channel if you want. Click the bell notification in my comment section or whatever, in my description like that, right? God bless everybody. Bye-bye. This is my last vlog for the day. Thank you so much. God bless.